All right, this is 31-1. We're taking a look at Rolle's theorem and the mean value theorem, and we're still in the applications of differentiation. So the first theorem we're going to talk about is Rolle's theorem. Now it says if we know that our function is continuous and it's on a closed interval and it's differentiable on that open interval, so all those preconditions have to occur. If we know that we have two values, f of a equaling f of b, I can make the assumption as a mathematician that there's at least a value for c, so c is an x value, so there's a value for x in which you're going to get a zero slope. Now this picture kind of helps us visualize it, meaning because this value and this value, the y values, they're equal, there has to be a value in between in which my slope is zero. And any picture that you draw, see, that has to be a zero slope. And it's just the way that the math has to work out. And so because of Rolle's theorem, it allows us to make an assumption. And it's very similar to almost like Descartes' rule of signs, where it allows us to make assumptions based upon the information. That's kind of like what Rolle's theorem is going to help us do. So our first example, it says for the function f of x equals x squared minus 3x plus 2, use the x-intercepts to show that there exists f prime x equals 0 between them. So there has to be a value in between in which I'm going to get a slope that's 0. So I need to start with finding the x-intercepts. So I have x squared minus 3x plus 2. If that's equal to 0, factor it. And so you get x equals 1 and 2. Now what this means is that's my interval, right? So if we're going to this theorem here, it's saying my interval from a to b, that there might be a value c that's between it that's going to give me the slope to being 0. So because I did find a value x for 1 and 2, they both give me 0, that means I can make the assumption that there's going to be a slope in between. And even doing like a rough sketch here, right? If I have 1, 2, so here are my zeros, right? My parabola is doing something like this. Just doing a rough sketch there. So the question is, what is that? How do I find that? And so first I have to take the derivative. So if I take the derivative of this, so f prime x is going to equal 2x minus 3. Then you take that and you set that equal to 0. So 2x equals 3 divided by 2. So x equals 3 halves. So at 3x equaling 3 halves, that's going to give me a slope of 0. And so that kind of verifies the Rolle's theorem, the fact that on an interval in which we get two equal values, f of a and f of b, they equaled each other, they gave me 0. There's going to exist a value that I can find for x that gives me a slope of 0. Next one, it says let f of x equals x to the fourth minus 2x squared. Find all the values for c in the interval of -2 and 2 such that f of c equals 0. So let's verify Rolle's theorem. So the first thing I need to check, does f of -2 equal f of positive 2, which equals 2 to the fourth minus 2 times 2 squared. So I have to verify that. Is that true? So that's for the positive 2, and here is for the -2. So that's going to give me 16 minus 2 times 2 is 4, 8. And over here it's going to give me 16 minus 8. So those equal each other. Both are going to be 8. So that tells me there's going to be a value for c in between them. Now, Rolle's theorem says there's at least one value in between. There could be more. I don't know. So there is a chance that I could get more when we go through and do this. All right, so now I need to find the derivative. So 4x cubed minus 2x. So now I want to set this equal to 0 and solve. So I can factor out a 2x, and I'm left with x squared minus 1. And I'm left with that factors into x plus 1, x minus 1. And so x is going to equal 0, -1, and +1. So those are all the values for c that are going to give me my derivative equal to 0. Now the mean value theorem, it says if your function is continuous on the closed interval and differentiable on that interval, then there exists a number c, so once again a value of c, in that interval such that this statement is true. Now this right here is the secant line. So basically it's implying that the slope of the tangent line equals that slope of the secant line. And so the mean value theorem is saying that that's true. A quick visualization, let's just say my function did this. That's not really a function, is it? The idea is that somewhere the slope that is between those two lines there, right, there's some value c for the x, right? If this is like some sort of like xy table, there's some value of x or c in which I could say that slope is the same. That's all that that's saying. So given f of x equals 5 minus x 4 over x, find all values of c in the open interval 1, 4 such that f prime c equals f of 4 minus f of 1 over 4 minus 1. That's essentially what it is, right? So this is my a and this is my b. So if we had f of b minus f of a all over b minus a, that goes straight from there. So first I need to find what that is. So my f of 4 is going to be, if I plug in 4, that gives me 4, so 5 minus 1, which is 4. Plug in 1, 5 minus 4 is going to be 1 over 4 minus 1. And so that's going to give me 1 because you get 3 over 3. So now I need to take the derivative. So if I take the derivative, I'm just going to get, I first need to bring it on top. So then taking the derivative, you get 0 plus, because I have to multiply. So you get 4x to the -2. So that just becomes 4 over x squared. So that right there is going to be my derivative. That, can I find a value for x that's going to equal that 1? That's the question. So 4 over x squared equals 1. Multiply both sides by x squared. And if I take the square root, x equals plus or minus 2. So these right here, those are the values for c that if I plug in positive 2 or negative 2 into my derivative function, if I plug them in there, it's going to give me the same value as that secant line. So to close this lesson, what is the mean value theorem? The mean value theorem states that if you have some sort of polynomial, some sort of function, right, has to be a closed interval, has to be differentiable, that the secant line between those 2 points, you're going to find some value for x in between those 2 points that if you take the derivative, it's going to equal it. So the slope of the tangent line is going to equal the slope of the secant line. And then Rolle's theorem, that basically states that if you have 2 y values that equal each other, we're allowed to make the assumption that there is a value for x in between those 2 values, in which if you take the derivative, you're going to get the slope of 0. This does conclude our lesson. If you have any other questions, please leave them in the comments.